What if all of a sudden the road just ended at the edge of a brown, silent river? Engine off, hot air sticking to your skin, the smell of diesel and wet wood, just the heavy sound of the wood flowing and a slow ferry out in the middle, deciding when you can continue your journey. For decades, for those leaving Rondonia towards Acre, this point wasn't just a detail on the route. It was a boundary. Here, between the Madeira River and the Abunã River, the border wasn't political, it was logistical. It's in this setting that the Abunã Bridge appears. A project costing over 150 million reais designed to turn waiting into continuous flow and free an entire state from dependence on the ferry. In Western Amazonia, this question was answered daily in lost hours, higher freight costs, and a sense of isolation. Stay with us for the next few minutes and see how 1.5 kilometers of concrete have permanently changed this crossing. The Abunã Bridge is located in the district of Vista Alegre do Abunã, in the far west of Rondonia, on the Brazilian Federal Highway, 364 highway, exactly where the road needs to cross the Madeira River on its way to Acre. More than just a point on the map, it is almost halfway between Porto Velho and Rio Branco, right in the Macro region, a development zone that connects parts of Amazonas, Acre, and Rondonia. It is about 1,517 meters long and just over 14 meters wide, with 2 traffic lanes, shoulders, and sidewalks. In other words, it's not just another bridge, it's one of the largest road bridges over fresh water in Brazil. According to the National Department of Transport Infrastructure, DENIT, about 2,000 vehicles cross this structure every day, reducing a crossing that could take up to 2 hours waiting in a ferry line to less than 5 minutes on asphalt. Here, it's not just about shortening travel time. It's about eliminating the last link of road isolation in an entire state and opening a direct corridor between the Brazilian Midwest, the Amazon, and the Pacific. But a bridge this big doesn't just appear. Next, we'll look back to see which problems, political decisions, and economic pressures led Brazil to confront the Abunã Música bottleneck. For decades, Acre lived in an almost symbolic condition. It was part of Brazil on the map. But in practice, it depended on a bottleneck of mud, ferries, and weather to stay connected to the rest of the country. The Brazilian Federal Highway, 364 acres backbone, running east to west, would get stuck right here at the river. Wood was transported by ferries in Abunã. In 2014, a historic flood submerged the highway, stopped the ferries, and left Rio Branco isolated from the other capitals for a long time. In practice, there was fuel rationing, skyrocketing prices, and supplies at their limit, and a clear lesson. Depending on a single highway corridor, crossing a large Amazonian river by ferry is a fragile gamble. Even on normal days, the crossing was expensive. Truck drivers paid about our dollar, $200 per vehicle, plus the lost time, risk of robberies, and unpredictability. This cost went straight into the freight, and in the end, into the price of rice, beans, and cement. Meanwhile, Brazil expanded its agriculture west and north. Mato Grosso, Rondônia, and the Macro region were gaining prominence in grains and meats aimed at the Asia-Pacific, but they still faced long journeys, congested ports, and expensive logistics. In this context, the Abunã Bridge began Phase 2 in 2010, was contracted in 2013, and, after the 2014 floods, became a political priority. And that's exactly where the most impressive part begins. How engineers and workers in the middle of the Amazon turned a muddy bottleneck into 1.5 kilometers of concrete over one of the most challenging rivers in the country. Music. From an engineering standpoint, the Abunã Bridge is above all a negotiation with a difficult river. The Madeira is wide, deep, has a large variation in water level between dry and flood seasons, and carries whole logs from the Amazon forest, which hit and pile up against the structures. The original design specified a length of just over 1,047 meters, but geotechnical and hydrological studies showed that to protect the highway from future floods, like the one in 2012, it would be necessary to raise the bridge and move the ends away from the flood zone. The solution was to add approximately 460 meters of viaduct on solid ground, creating 3 distinct sections: the elevated part on land, the section over the shallower riverbed, and the central navigable span. This adjustment also required almost 1.5 kilometers of embankments at the access points, smoothly connecting the Brazilian Federal Highway 364 to the deck, raising and reinforcing the structure against future floods. In the foundation, the key word was depth. The soil of the alluvial plain in the Madeira is predominantly soft, saturated, and has low bearing capacity. To anchor the bridge, about 145 deep piles were driven, supported by more resistant layers. In a delicate operation carried out from barges and floating platforms, often under strong and variable currents. The foundation used about 29,000 cubic meters of concrete and over 4,000 tons of steel, including precast beams, slabs, and foundation blocks. At the peak of the construction, around 160 workers took turns between reinforcement, formwork, concreting, assembly of support devices, and deck protection. The conventional section of the bridge, over the banks and shallower areas, was built with typical spans, using beams launched from cranes and assembly trusses, with temporary decks supported by metal towers. The 175-meter navigable span needed a more advanced solution: the balanced cantilever method, using concrete segments. They are built at the same time, starting from the pillars and extending over the river like arms that meet precisely in the middle, accurate to a few millimeters. While the superstructure was rising, the geotechnical and earthworks team was fighting another enemy: the embankment of the access roads in a soft soil environment. Bringing in large embankments always carries the risk of differential settlements. It was necessary to control loading rates, perform preloading, and monitor deformations to ensure that, in the future, the transition between the road and the bridge would not turn into a step, a common problem on highways over floodplains. The schedule, which originally called for about 4 years, ended up being extended by another 6 months. Part of this was due to unpredictable events. A barge hit a pillar under construction, and severe floods halted concreting. And, already in the final stretch, the COVID-19 pandemic reduced work fronts, affecting the supply chain and shifts. The contractor responsible for the execution also faced a logistical challenge typical of the Amazon. Almost everything: cement, steel, special equipment. It had to travel hundreds of kilometers by highway, often on stretches still under repair, to reach the construction site set up in the middle of the forest. In the end, the result is a curved deck about 30 meters above the water level, at the highest point, with a roadway about 14.5 meters wide, side shoulders of approximately 2.5 meters, and sidewalks of 1.5 meters. It's not just an elegant object in the landscape, it's a geometry designed to provide comfort for the heavy fleet of the Brazilian Federal Highway 364, which carries millions of tons of grain every year from Rondônia and the western and northern regions of Mato Grosso. Today, the crossing, which used to involve waiting in line, maneuvering to board, a slow crossing, and another line to disembark, has become a continuous 2-hour stretch of asphalt. On bad days, for less than 5 minutes, music. Despite its key role in northern Brazil's transportation, the Abunã Bridge sits between a mega-urban bridge and a major regional project. With a length of 1,517 meters, it would be long enough to line up about 14 to 15 official soccer fields in a row. As for the investment, estimated at around $R millions to $154 million, it results in an average cost of about $1,000 per linear meter. This level is compatible with large-scale projects in complex river environments, with deep foundations and significant variations in water level. It is worth highlighting that the Abunã Bridge serves as a link in a long-distance corridor, connecting states and bringing Brazil closer to the highway route toward the Pacific. Compared to the old ferry operation, the contrast is even more striking. Previously, a heavy truck paid a little over R for each crossing. With a daily flow of 150,000 to 200,000 vehicles, even if just a third are trucks, the system could earn R110,000 to R160,000 daily or R millions to R60 million annually from toll fees alone, not to mention the time lost in lines and the diesel burned while idling. Today, this toll barrier disappears. The crossing becomes a continuous part of the highway. Now, when it comes to materials, the approximately 24,500 cubic meters of concrete mentioned in official data is roughly equivalent to what's needed to build dozens of medium-sized residential buildings. The 3,500 to 4,000 tons of steel used is nearly equal to what's in the metal structure of a small stadium. In terms of logistics corridors, there are few points on the map that connect at the same time to the National Highway, the Madeira-Amazonas Waterway, and the road route to the Pacific. How does Abunã make music today? In the short term, the most tangible effect of the Abunã Bridge is directly on people's wallets. Without the ferry fee and with reduced travel time, the cost of transportation is significantly lowered, which can make food and construction materials cheaper, especially for lower-income people in Acre. On a larger scale, the bridge consolidates Acre as a functional part of the federal highway network and strengthens the Porto Velho Peru border route via Brazilian Federal Highway 317 and the Pacific Highway. With this, meat and grains from Amacro can reach the ports of Matarani and Hilo faster, shortening the route to Asia and the Pacific, and increasing the competitiveness of refrigerated products with higher added volume. But there are counterpoints. The same infrastructure that connects markets can accelerate the uncontrolled advance of the agricultural frontier, repeating in a macro the cycle of deforestation, logging, cattle ranching, and grains seen in other regions. In addition, the bridge eliminates a road bottleneck, but not the climate vulnerability. Recent extreme events show that relying on a single mode of transportation remains risky. That's why studies advocate for a multimodal and resilient network, combining highways, waterways, and robust intermodal terminals. In summary, the Abunã Bridge is a gigantic step forward, but it needs to be accompanied by territorial planning, environmental control, and complementary investments so that development doesn't consume the ecological foundation that sustains it. In the end, the Abunã Bridge is not just concrete and steel in the Amazon. It's the precise application of engineering to read a difficult river, understand a vulnerable territory, and turn isolation into connectivity. The old dependence on the ferry here gets a technical solution, the result of thousands of tons of materials and years of work. Sometimes the difference between being on the sidelines and being integrated fits into 1.5 miles of bridge. Thank you for watching until the end. What are your thoughts on this bridge connecting Acre to key regions for its economic growth? Share your opinion in the comments. Well, we have some people from Acre sharing their thoughts here in the comments. I'll be waiting for them. And that's it for now. A big hug and see you in the next video.